Hello stats fans, and welcome to chapter 2. In this chapter we're going to be talking about different ways of organizing data. And we start off with section 2.1, where we're going to learn about histograms and some related topics. So to get started here, it mentions that when conducting a statistical study, the researcher must first gather data. So this is what we talked about earlier in chapter 1. Then the data must be organized in some meaningful way. So when we gather the data, we're just going to have this giant pile of numbers, and we need to organize these numbers in a way where we can get information from them. So this section talks about making these histograms. But to make a histogram, we first make what's called a frequency table. So out of all of these things we'll learn in chapter 2 about displaying data, histograms are the most complicated. And they're not really difficult complicated, there's just a lot of steps. So every other way of displaying data is much easier. Like a bar graph is much easier. A histogram, though, has a lot of steps. So I'm going to go through the steps here, and you can follow these steps on every one that you make in the homework, and they all pretty much follow the same pattern. There's a lot of steps to a histogram. So what we'll do first is we're going to make a frequency table. Then from the frequency table is just a way of organizing all the data. So once we have our frequency table, we'll look at the frequency table and then build our histogram from that. Okay, so to get started here, when we have a large set of quantitative data, so remember there's quantitative data, and what's the other one? The other type? Qualitative data. Quantitative and qualitative. And what's another word for qualitative? Hopefully you're thinking categorical. So quantitative and qualitative. Qualitative, as I mentioned, is sometimes called categorical. But quantitative, remember, think of it like quantity. It's like a number. So quantitative data, these are data points that we can talk about things like the median, and it will make sense. So we're talking about, for right now, with histograms, we need quantitative data. So when we have a large set of quantitative data, it's useful to organize the data into smaller intervals or classes and count how many data values fall into each class. This is exactly what a frequency table does. So classes are just like groups. We're just breaking the numbers up into different groups or classes. So we start off with how to make a frequency table. Remember, we're going to make a frequency table first, then look at the frequency table and use it to construct a histogram. So for this first one, let's look at, let's go with page 57, number 16. So we want to look at problem number 16 from section 2.1. And in the book, it's on page 57. But if you look at number 16, you'll see that it has to do with glucose testing. It says the following data represent glucose blood levels in milligrams per 100 milliliters after a 12-hour fast for a random sample of 70 women. So we've got 70 numbers there. And when you look at it, it just looks like a pile of 70 numbers, right? We want to make sense out of those numbers. We want to take those numbers and make a picture out of those numbers, and that picture will give us information about how the numbers are distributed, and that's essentially what a histogram is. So if you look at the steps here, it says determine the number of classes. Normally used between 5 and 10 classes. So there's a couple standard ways to do this, but we don't need to know either one of them. Because if you look at the bottom of the numbers on number 16, at the very bottom, what 3 words do you see? If you look, you'll see it says use 6 classes. So our book will always tell us. And look right below that, problem number 17 has a list of numbers and what follows the numbers. And number 17 says use 5 classes. And then number 18 at the bottom of those numbers use 7 classes. So our book will always tell us how many classes to use. Okay, so the note here is our book will tell us how many classes to use for each problem. Okay, so that'll always be the case. We never have to calculate anything. They'll always tell us how many classes to use. So once we know how many classes, we have to determine what's called the class width. And there's a little formula here for it. So we have to compute the largest data value minus the smallest data value over the number of classes. So looking at that pile of numbers there, there's 70 numbers for number 16. Take a minute and see if you can find the largest number and the smallest number. You're not just waiting for me, are you? Okay, so if you look, you'll probably say it looks like 109 is the largest number. And it looks like 45 is the smallest number. So we just go largest minus smallest. We're going to divide by the number of classes. How many classes are there? 6. How do I know the number of classes again? How do I know this? It's given, right? Underneath all the numbers, it says use 6 classes. So this will be given to us in the book. So we have to look in this set of data, find the largest number and the smallest number, and then subtract the 2 and divide by the number of classes. So in this case, we get 64 over 6, or roughly 10.67. Okay, so we've got this number. Then part 2. This is important. I'm going to use red. What does red mean again? Danger. Danger. Below star, always. Always increase this value. What value? This value right here. Always increase this value to the next highest whole number. Okay, so I'm looking at this. Increase this value to the next highest whole number, and that will give us my class width. So that means that class width equals 11. Okay, here's where we get tripped up all the time. Notice, look at this sentence and tell me, when it says always, do you think that means sometimes always or always always? Always, always, right? It doesn't say round, it says increase. Always increase to the next highest whole number. We have to do that to guarantee that when we go through this process, all the data points will have a class to go into. Okay, so as an example, let's just say we had this one. I'm totally making this up. Let's say we went through this math. Let's say we had a problem where we went largest minus smallest. Let's say there's 10 classes, and we get 70 over 10, which is 7. Okay, let's just say this. In this case, what's the class width going to be? Is it going to be 7 because we're rounding? No, look what it says. Always increase this value to the next highest whole number. It doesn't say anything about rounding. Always increase. So the class width in this case would be 8, right? So I have to emphasize this a lot because this will get tripped up here. Always increase. Just follow down here, do it exactly what it says. Always increase. I didn't move this to 11 because I was rounding. I moved it to 11 because I always increase. Same thing here. Had I had 7, let's remember I just made this up. This is not the problem that we're looking at. This is just an example. If I got a whole number like 7, I always move it up anyway. Always increase. Okay, so that's the class width. So the class width for us, for our problem, is 11. Right, so we got the class width equals 11. So just so there's no confusion, I'm just going to get rid of this. Remember, this is just an example. Okay. So then it says create the distinct classes. It says smallest data value equals the lower class limit of the first class. Okay, now this is going to be a little tricky because normally in class I use 2 whiteboards right now. So we're going to figure out how to make this work here. So basically what I do is down below here, we take this little chart here and we start filling in the blanks here. So it's going to be a little tricky because I'm going to have to keep moving back and forth here. So it says create the distinct classes. Smallest data value equals the lower class limit of the first class. Well, our smallest data value we already found that was 45, right? This is our smallest data value, 45. That's going to be the lower class limit of the first class. So go back over here and I'm going to write 45 to something. I'm just going to write 45. It's the lower limit of the first class. Okay. And then if you look at the handout, number 3, it says add the class width to this number. So it wants us to add the class width to this number to get the lower class limit of the next class. So remind me, what was the class width again? 11, right? So I'm going to write this like this. So you're going to want to do this too. If you've never made one of these, let's write plus 11. And when I add that, that's going to give me 56 to something. Right? And all I'm doing, I'm looking at number 3 here. I'm doing this. Add the class width to this number right here to get the lower class limit of the next class. Continue adding the class width until you have the correct number of classes. How many classes are we going to have again? 6, right? Because that's what the book told us. So go back over here. And I'm going to keep doing this. So I just keep adding 11. So I add 11 again. That'll give me the third class. I add 11 again. So let's see, we'll get 67, we'll get 78. So I got 4 classes so far. We need 6, so I'm going to do this 2 more times. Plus 11, plus 11. So I get 89 to something and 100 to something. And we stop here, right? Because we want 6 classes. So we've got 1, 2, 3, 4, 5, 6. So I stop. Here's the key. Don't add this way. That's why I put this in red. Because the number 1 mistake here is to add this way. And if you do that, everything you write here is going to be wrong. So you want to add this way, right? Okay, so we've got these numbers. And then we go back up here. And look what this part says. Fill in the upper class limits to fill in the gaps in the table. Here's what that means. So remember this right here, this whole thing is our frequency table. We're just going to fill all this table out. So the class limits, this first one starts at 45 and goes to some other number. Now the way we figure out what this number is, we look at this one. Well, 56 is going to be in this class. So if 56 is here, what's the highest this could be? 55, right? The highest this could go to is 55. So that's what it means by fill in the gaps. So same thing here. So if this goes 45 to 55, so here's 56. How high can this go? Well, it can't go to 67 because 67 is here. So how high could it go? 66. Just think of integers, right? We don't want like 66.2 or anything. Just integer values. Okay, so looking at that, see if you can predict these. Don't wait for me. Just go ahead and fill them in. See what you get. Looks like we are going to get 77, 88, 99. Now, what about this spot? I can't look here to get the next one. So for the last one here, what we have to do, by then you'll be able to see a pattern. What do I do to get each of these? Don't we just add 10? So I'm going to add 10 here. Get 110. Okay, so that's how we create the distinct classes. So there's 6 classes. Our book told us that, right? We wanted 6 classes, and here they are. The lower class is 45 to 55, and then here's another class. And so there's 6 of them all together. Every number in our data set should fit into one of these classes if we did this correctly. Okay, so we've got these. Now let's see what we do next. It says, for number 4, step 4, tally the data into these classes. Total the tallies to obtain each class frequency. Well, frequency means basically how many, right? Here's the part that is where you're going to understand why this is not done by hand anymore. In fact, I'll let you in on a little known secret. Do you know who it is who makes histograms by hand? There's only one type of person. First-year stat students, that's it. So you had to do these by hand the first time just to see how everything works, but beyond that, this is all done on computers. There's statistical software does this, or even something like Excel, or in our case, our graphing calculators too. But the first time you do it, you just kind of have to do this by hand to develop the intuition that you need. So we'll do them by hand. They won't be huge data sets. Like in reality, data sets are typically much larger than this, but even with 70 numbers, it's going to be a handful. It really is. So this is what we're going to do. Total the tallies to obtain each class frequency. So here's what we do. So what we're talking about is frequency. So we want to look in those 70 numbers and see in that pile of 70 numbers, how many numbers are between 45 and 55 inclusive, meaning including 45 and 55. And this is not easy to do. So when we do this in class, I have students come up to the board and give their answers, and we get a whole bunch of different answers here, because you'll see it is definitely not easy, especially in these here where there's a decent amount of them. It is not easy to count. Like for instance, this one. It seems like it might be easy, but it's not. It is not easy to count how many numbers are between, in that pile, are between 78 and 88. A lot of times if you do this 4 different times, you'll get 3 or 4 different numbers. It's just not as easy as it seems, which is another reason why this is not really done by hand. But to see what I mean, if you look in that pile of 70 numbers, problem number 16, you will see that there are 3 numbers in that pile between 45 and 55. So the frequency here is 3. And I'm just going to draw these dashed lines in here just to kind of keep track of where we're at here. Otherwise it gets sometimes hard. But we're talking about 3, meaning if you look at that pile of numbers, 70 numbers, there are 3 numbers in that pile between 45 and 55. And then you're going to want to do this to verify. Like, histograms are not really difficult, but there's a lot of steps. And you're going to want to do this with me so that when you have to do it on your own, it won't be your first time, right? So do this with me. Don't just wait for me to write them down. See how many numbers are between here. And of course, just pause this video when you need to count them. And then numbers between here. So if you do that, you'll find eventually, it might take a couple tries, but you'll find out that there are, okay, so you'll find out that there are 7 numbers. So 7 numbers in that pile of numbers between 56 and 66. 7 numbers there. So go ahead and press pause and fill these out. Remember, there's 70 numbers altogether, so when we add up all these frequencies, we should get 70. Okay, so if you did that, you find out there are 22 here, 26 here, 9 here, and 3 here. It's not easy to do that without making any mistakes. And if you add those up, you get 70. So those are the frequencies for each class. And again, what that means is in that pile of 70 numbers, there are 9 numbers in that pile that are between 89 and 99, including 89 and 99. Frequencies, how many? These are called the class frequencies. This class here has 3 numbers in it. This class, 56 to 66, there's 10. In other words, there's 10 data points in that pile of numbers between these two numbers. So it was supposed to say 7 here, not 10. Sorry about that. So that is the frequency. Very tedious. That's a very tedious part of making a histogram when you're doing them by hand. So then we go back on our list here. Total details to obtain each class frequency, which we just did, right? So now we compute the midpoint for each class. So the midpoint, this is a formula just basically from geometry, the midpoint of a line segment. Right? You can add the coordinates and divide by 2. So it's just like that. We're going to find the lower class limit plus the upper class limit divided by 2. So we're going to find the mean of those two. So find the midpoints. We go back down to our list and we find the midpoint. So for this first one, the midpoint here, if we add these two, 45 plus 55 is 100. Divide it by 2, we get a midpoint of 50. And it's exactly how it sounds. The number 50 is right in the middle of these two, right? So take a second and fill these in on your own, right? Just add these up, divide by 2, add these, divide by 2. So do that, take a minute and do this, and then come on back. Okay, so hopefully you did 60, you figured out 61, 72, 83, 94, and 105. And again, to find the midpoint, all we do for 105, we add these two numbers. 100 plus 110 is 210. Divide 210 by 2 and you get 105. So this is the number. 105 is right in the middle of these two numbers. So that's the midpoint. Okay, so if we go back on our list of steps, because remember this, we're making a frequency table. This whole thing is our frequency table. So looking back at the steps, it says after number 5, number 6 says determine the class boundaries. Okay, so let's go back up here. Determine the class boundaries. So notice that we've got class limits. Well, when you make a histogram, you start off with your frequency table with class limits. We always start here, but then we go to class boundaries. Also, let me mention one more thing that comes up all the time. This happens constantly. Notice in the class limits, 45 is in our data set, right? Because to start here, we have the smallest number in the data set, 45. What happens all the time is on a test or a quiz, students will get confused here because they expect this to end at 109, but it doesn't have to end at 109. 109 is our largest data point. It has to be at least 109 because we have to, this last number has to be big enough to contain the largest number. So while this number will always be from our data set, because that's how we started, right? This is the smallest number in our data set. This number is not necessarily the largest number, but it will be at least as big as the largest number, right? Because the largest number is going to fit in this last class. So just kind of keep that in mind. This number here does not have to be a number in our data set. And it's not in this case, right? 110 is not in there. 109 is. So I just thought I'd mention that while I was thinking about it. But back to what we're working on. So we just figured out the class limits. Now we need to find the class boundaries, and that's done right here. So determining class boundaries, we add 0.05 to the upper class limits. Okay, now these numbers here are the upper limits of each class, right? In other words, 99 is the upper limit of this class. And these numbers are the lower limits of each class, right? So 56 is the lowest number in this class here. So to get the class boundaries, we add 0.05 to the upper class limits, all of these. Subtract 0.05 from the lowest class limits, all of these. So when we do that, we get something like this. So 45, I'm going to subtract 0.5, I get 44.5. Now 55, I'm going to add 0.5, so I get 55.5. Likewise over here with 56, I subtract 0.5 and get 55.5. 66, I add 0.5 and get 66.5. Then over here with 67, I'm going to subtract, get 66.5. And you'll notice when you do this, as you go, these numbers are the same, right? These are the same, and these are the same. Well, the class boundaries, the reason we do this is because we want to make sure that none of our data points land on one of these lines when we make a histogram. And putting this 0.5 guarantees that it won't, because if you look at all of our data, all of our numbers there in that set of 70 numbers, they're integers, right? There's no decimal points. So by doing this, we guarantee that if we use these class boundaries as lines on our histogram, kind of like a bar graph, these would be like the border lines, and none of the numbers will end up on a line, which is what we want. Also, the other thing it does is it makes sure that our lines will touch, which we'll see because these are the same numbers, these are the same, these are going to be the same. So if we go down here doing the same thing, this will be 77.5. So just go ahead and fill these in. So what we have to do is add 0.5 to the upper class limits, subtract 0.5 from the lower class limits. And eventually we will get to the end here. Okay, so we've got the class boundaries, and these class boundaries, these are the numbers we're actually going to use when we make our histogram. Okay, we get started with our frequency table with the class limits, but we tweak these a little to determine the class boundaries. These are the numbers we're going to use. So just make a kind of a note of that. These are the numbers we're going to use when we make our histogram. We use those class boundaries, not the class limits. Okay, so there's a couple of notes here. These notes will make more sense when we actually make our first histogram. But for now, we can say this. The first note is, this assures us that no data values will fall on the class boundaries. Okay, which I talked about before. And again, that'll make sense when we actually draw one of these. And it does one more thing, and causes the bars of the histogram to touch, which is what we want. Okay. And then there's another note here. The other note is see page 47. And there's a little section under the comment on page 47. And basically they're just going to mention that although we are going to make these histograms in class with these class boundaries, when you see them in reality, when you see them in advertising and marketing, they typically don't do them this way because there's sometimes a little too much happening when you use all the class boundaries. There's decimal points. And you typically want to express an idea that's a little neater and easier to see. So it just mentions that. So we're gonna make them with these class boundaries, but a lot of times when you see them in reality, they might use like class midpoints, or they'll make them a little easier to see. So when you get a chance, just take a look at that. Just a little paragraph there. It says comment, and then they talk about the use of histograms. And I guess while we're here, we'll just fill in these last couple of columns. We actually have everything we need to make a histogram. We actually didn't even need the midpoint for that. But sometimes they will want us to make what's called a relative frequency histogram. So we'll need one more column for that. And also they're going to want us to make an ogive, which is sometimes called a cumulative frequency curve. So we're going to need another column for that. So the relative frequency, this column here, basically says, okay, in this class here, in this first class, there were 3 data points. So the relative frequency would be 3 out of 70, right? 3 of the data points out of 70. So we're going to end up getting a decimal that represents the relative frequency. And this is a good chance to practice rounding. So usually in class, what I do is have students come up and write their answers here, and I would say round to the 4th decimal place, because rounding for some reason gives us trouble. We're going to use conventional rounding. So conventional rounding is like this. It just says, let's say you've got a number like 3.14159. Some of you guys may recognize that. It's approximation for pi, which is the ratio of circumference of a circle to its diameter. So let's say we wanted to round this to the 4th decimal place. So we want to round it to right here, the 4th decimal place. And just a little review. This is the 10th place, right? Tenths, hundredths, thousandths, 10,000ths. 10th, because doesn't this 0.1? Doesn't 0.1 really represents 1/10, right? So it's a 10th place. So over here is the ones, right? And then the tens. But on this side, you start with the tenths, right? Tenths, Tenths, the tenths place, then hundredths. These are like my least favorite words ever. See if you could say this word really loud without spitting all over the place at the end. It's a terrible word. Thousandth. It's like you can't do it. I hate all these words because of that. But anyway, we need to know how to use these numbers. So if we're going to round to the 4th decimal place, or in other words, just for practice again, tenths, hundredths, thousandths, 10,000ths. To round there, we're going to use traditional rounding, which means look at the next number, and this number is going to tell us either leave this alone or move it up 1. And it all depends on if it's 5 or more, right? So in this case, 9 is bigger than 5. So if we were to round this one, we would round it to 3.1416, right? Also, you can only round once. You can't keep rounding numbers down, because sometimes students will round once and they round again and again, and you end up getting the wrong answer because you round to your one spot. So if you're going to round to the 4th decimal place, you round to the 4th decimal place, and that's it. You don't round again after that. All right, so if we're going to round to the 3rd decimal place, we're going to round to the 3rd decimal place. Well, in that case, let me clean this up a little. In that case, we're going to round to the 3rd decimal place. Running right there. Again, that's the tenths, hundredth, and thousandth, right? This one, thousandth. So if we're going to round there, we look at the next one, and it tells us either leave this alone or move it up 1. In this case, because it's 5 or more, we move it up 1. So it would be 3.142, right? So just a little practice. So the relative frequency is just a frequency divided by how many there are. So if you go 3 divided by 70 on your calculator and you round it to the 4th decimal place, you should get 0.0429, right? Because 3 over 70, If you punch that in your calculator, 3 divided by 70, that will give you 0.042857142.9. Of course, keeps on going. So if we're going to run to the 4th decimal place, that's right there, right? We're going to look at the next number over, which is a 5, which means move this up 1. So go ahead and figure these out. It's just basically whatever the frequency is divided by n. I can even put this. So sometimes frequency, they use this like scripted f. Then relative frequency would be scripted f divided by n. And n is the sample size. N is the sample size. So in this case, the sample size is 70. There's 70 data points. So if we keep going, we get 0.3143, 0.3714, 0.1286, and 0.0429. Now, what would happen if I were to add all these together? What should I get? In theory, I should get 1, right? And we do, other than the fact that we're going to get some round-off errors, right? I mean, this is just from rounding. If we kept this as 3 over 70, 10 over 70, 22 over 70, if we didn't round anything, then we'd get 70 over 70, which is 1. So relative frequency should add up to 1, or something really close because of round-off errors, right? So it's a relative frequency. We're going to use this if we have what's called a relative frequency histogram. We use this for just what's called a histogram. Then cumulative frequency, well, this is we're going to add everything up and see how things add up cumulatively. So cumulative frequency, it's a little tricky at first, so hang with me a second here. Just think, if you look at this first class, we've got 3 data points. So at the end of when we get to the end here, 45 to 55, we have a total of 3 pieces of data. Okay, now for the second class, now we're going to add this class in. And when we do that, we pick up another 7. So 3 plus 7 gives us 10. So we've got cumulative frequency of 10. So remember, that means that cumulative so far, by the time we get to the second class, we had 3 here, another 7 here, which makes 10. So now when we get to the third class, by the time we're done with that, we pick up another 22, right? So now we have a total 10 plus 22 gives us 32. Right, and all that means is that 32, if you add all these together, we get 32. So we go along here, we pick up another 26, and that'll give us 58. And we keep on going. We get to this class, pick up another 9, right? We had 58, plus another 9 gives us 67. And then finally, we go to the very end. We pick up 3 more. 67 plus 3 gives us 70. And we knew we had to get 70 because that's how many data points there were altogether. So what you're looking at right now is our completed frequency table. This is our frequency table with everything we need to make our histogram, and our relative frequency histogram, and our ogive. So this column here, we'll use this column. I just add a couple things here. We're going to use this column right here to make what's called a relative frequency histogram, which are not as popular, by the way. And we use this last column here to make what's called an ogive, or a cumulative frequency curve. And we use this frequency column to make our histogram. So mainly what I concentrate on making is a histogram, where we use this frequency column. Now I know you guys are super excited. You can't wait to make your first histogram ever. So right below this table on your handout, what we need to do Let's see, where is it? Yeah. I didn't leave a lot of room here. But we need to make two little graphs here. So one here and one in here. Or you can do it on a separate sheet of paper, of course. Let me clean this up a little. Make a little room here. And what we'll do is make a histogram, and then we'll make a relative frequency histogram over here. So I'm looking at this little fill in the blank. I guess we can fill this in real quick. So a histogram is a graphical representation of the distribution of data. And we'll see when we make it what that means. So we're going to make a couple little graphs here. So the first one I will make right here. We need a vertical axis, which will be our frequency. So make a vertical axis here for our frequency. Make a horizontal axis, which is going to be class boundaries. So I have this horizontal axis here. Class boundaries. So we just look at our class boundaries. So we've got 44.5. And then we just fill them all in. Try to keep them fairly evenly spaced. We're doing it by hand, so it won't be perfect, but we can make it pretty good. 66.5, 77.5, 88.5, 99.5, and 110.5. Now, when you look in the book, you might notice something. I'm going to make a little more room here to show you what you might see in the book. I'm going to just erase this a second. And, okay. So make a little more room here. And sometimes in the book you'll see this little mark down here where you'll see, I don't know why it keeps doing that, but you'll see this little mark. It means that the scale is changing. You don't have to put those there. Sometimes you'll see them like this also, where you'll have something like this. It just means that the scale is not consistent there. In other words, these are jumping by 11, right? So this clearly can't be a gap of 44.5. So you put this little jump scale squiggle or something like this. Totally optional. You don't have to. The reason sometimes I hesitate to even show it, because then I see, we'll have things like this. And this will be, 2, 4, 6. So you don't need it in this case, right? It's not needed here. It's actually misleading to put it there. So you only need it when you're showing that the scale is not consistent. Like if this were a 0, this is definitely not consistent because these are about gaps of 11. So you can put them if you want. You don't have to. I just want you to be aware of it because you'll see them in the book. Okay, so once we have our horizontal axis, then we've got our vertical axis, which is going to be our frequency. So look in the frequency column that we just made, and the largest number you see in there is 26, right? 26 is our largest number. So we need to go to at least 26. So I will go to 30 just to make it kind of easy to deal with. I'll put a 30 up here because if this is... sometimes the software is just too much. Okay, 30 is here. Then we could go, let's go like 10, 20. Again, I want to try to be consistent, but we're doing it by hand, so it's just not going to be perfect, right? So Like 5, 10, 15, 20, 25. What you don't want to do is just be totally sloppy, you know. You don't want to just do, let's see, 5, 10, 20, 25, 30. You know what I mean? It's sloppy. The gaps are not consistent. So you don't want to do stuff like that. How many undos do I need? Okay. Whoops. Okay. So we've got our we've got our horizontal axis, we've got a vertical axis, and now we just have to fill in the blanks. So this over here, the vertical axis, this is frequency. And when we make our graph, we want to make it so that everybody can read it and they know exactly what this is. So when you look at this, is this $55.5, 55.5 guppies, 55.5 people? No, it's glucose readings, right? So we want to say what these are. This is glucose readings. We'll say glucose in milligrams per 100 milliliters. So every time we have a graph, if we've got a horizontal axis, we need to label it. Vertical axis, we need to label it. Okay, we have to label these. We want to make it so that anybody can look at this and immediately know what these numbers represent. So we need that. It's important. Then for the histogram, we just fill in the gaps here. So if you look at the frequency, we know that we have got 3 data points in that list of numbers between 44.5 and 55.5. So we just make our graph. So this goes to 3. Again, it's not going to be perfect because we're doing it by hand, but this is 5 here, so go to about 3. The next one, if you look at our frequency table, the next frequency is 7. So I want this next one to go to about 7. Right, then the next one, we've got 22, so it's going to jump up to 22 for this next class. Get 22, right, because I'm just looking at our frequency table, right, we had 22, so if you look where I'm getting the numbers from, 22, right here, 22. The next one's going to be 26. So I've got 22 data points in this class. Right, that's where the 22 is coming from. So we come down here and make this, the one after the 22 is a 26. So we make this 26. And then we've got 9 in the next one. And then finally 3 in the last one. So the histogram shows a distribution of data, right? It shows that there's a lot of them in between here, between 66.5 and 88.5 in our glucose reading. There's one more important thing we need, and that's a title. We want a title to show what this is about. So what I'm going to write is, I'm just going to write histogram for glucose blood levels. Histogram for glucose blood levels. And you can give your name, your title, whatever you really want, just something that describes the data you're looking at. And you don't even have to have any intuition about this, which most of us don't. But I'm sure some of us do. Some of you are going into the health fields, in the healthcare. So you probably have some intuition about this. You probably think, wow, there's 3 people over here. That's pretty high, right? But the rest of us don't need to have that intuition, but we all have to be able to read it and know what it means. That's what we need. So we need to be able to see, looking at this, these numbers refer to glucose. This is a histogram for glucose blood levels, and this shows the frequencies, right? It shows that in that set of numbers, there were this many, roughly 3, well, there were 3 there, between 44.5 and 55.5, right? So we just have to read it. So when we're creating these, we need to make sure we label these axes and we put a title. So this is a histogram. Histograms use the frequency column of our frequency table. Now, another one that they'll ask us to do sometimes is a relative frequency histogram. Well, the thing about a relative frequency histogram, it's going to be this exact same shape. And the reason for that is there's a relationship between frequency and relative frequency. So frequency is 3, relative frequency is just 3 divided by 70. So this is the largest number in the frequency column. Doesn't that mean this is going to be the largest number in the relative frequency column? Because isn't this number just this divided by 70? Right? So there's a relationship here. So these are going to be proportional to one another. So if I have a histogram, remember the histogram uses this frequency column. A relative frequency histogram will use this column, but because these are proportional, it's going to look the same. The shape will be the same. What will be different is instead of the vertical axis being frequency, the vertical axis will be relative frequency. Okay, so I'm going to, right next to this histogram, I'm going to draw a relative frequency histogram, but you're going to see they look just the same. One thing you'll also notice when you look at this, when we have a histogram, the bars touch, right? 55.5 is shared by both of these class boundaries. So we wanted the bars to touch. Also notice this is an actual number line. Our number line consists of these class boundaries. And again, when you see these, typically you don't see them like this. It's just a little awkward to see all this in here. So typically you'll see midpoints or something that'll be a little bit neater. But this is how they want us to do them. And typically this is how you do them as a first year student. You put these class boundaries in here with these, which in our case will always be a 0.5. So to make a relative frequency histogram, I can draw pretty much what we just drew here. I've got a vertical axis, but instead of frequency, it's going to be relative frequency. The horizontal axis is going to be just the same, so I can still put this little jump scale if I want to. Again, it's optional. You don't have to do it. So this is going to be exactly the same. These are the same numbers for horizontal axis. So I can put these in here. And get one more, 110.5. Now, of course, here we're going to have the relative frequencies for the vertical axis. And the largest relative frequency, if you look at it, is 0.37. So what I would probably do is I would just make this go to 0.4. So let's say just to make it easier to do with 0.4, 0.2, 0.3, and 0.1. That's probably the easiest way to do it. And then we can just fill in the blanks. So this first class here, 44.5 to 55.5, the relative frequency is 0.0429, 0.0429. So it's basically like if this were, this is like 0.10, we've got 0.04. Okay, so we've got about 0.0429. And this one is 0.10. And then we got 0.3143, so this one comes up. 0.3143, and again, we're doing it by hand, so it won't be perfect, but it's going to have the same shape as the last one, right? Because these are all proportional. 0.3714. And 0.1286. And then 0.0429 again. Okay, and again, we always want to label. We got a horizontal axis. We need to label it. So this is glucose in milligrams per 100 milliliters. Over here, we don't have the frequency. Now we have the relative frequency, right? Relative frequency. And the title here won't be histogram, but relative frequency histogram, right? So this is going to be the relative frequency histogram. For glucose blood levels. Okay, and of the two, I'll usually ask more about a regular histogram than a relative frequency histogram. But that's how you make them, and you can see that they are the same shape in this case because these relative frequencies came from taking these frequencies and dividing them by 70. So that's how you make a histogram or a relative frequency histogram. They're a lot of work, honestly, compared to everything else we do. So the other ones that we do will be a little easier to work with. While we're right here, another one that's related is an ogive. Now, whenever I've seen an ogive in reality, other than in our book, they're typically, I'll see an ogive on top of a histogram. So I'll see this histogram, then there's an ogive on top of it. But in our book, we draw them separately. So we can just take a look at that because it has, some things are going to be similar. But an ogive is a graph that displays cumulative frequencies. It's an cumulative, cumulative frequencies. And I think I mentioned this before, it's also called a cumulative frequency curve. A cumulative frequency curve. Our book just calls it an ogive. So when you see them, a lot of times they'll be, I'm just going to kind of quick sketch this in here. You'll see it like they'll be kind of scattered on top of one of these. And they'll go through the histogram. So this would kind of keep on going. Actually doesn't ever go back down, but it'll be like on top of the histogram. But we do them separately in here. So let's just make one of these real quick. Now, when we make these ogives, we can basically have this same, we have a vertical axis, we have a horizontal axis. The horizontal axis will actually be exactly the same. Just like these two are the same, our ogive will have the same also. So let me just sketch this one. And we'll see that we've got, for our ogive, we've got our vertical axis just like before. We've got the exact same horizontal axis, so if you wanted to, you could put the little, I'll put this other kind in here. Sometimes you'll see these. It means the same thing. It means the scale is not consistent through there. And then all this is the same, 44.5. Remember, don't use one of these unless you have to. If this were a 4, that's not really much of a difference. So if we're like 4 and here's 8 or something like that, it's not big enough difference to put this. We put this here because this gap of 44.5, you know, if we were going to be consistent, we wouldn't want to have a histogram that looks like this and starts way over here, right? And all this is just empty space. So we condense this, and we do that by using one of these or one of these, right? So that's what they're for. All right, so get rid of this stuff a second. And keep on going here. And a couple more. Okay, and this is the same as before. This is glucose in milligrams per 100 milliliters. Now in this case, so for an ogive, we're going to use from the the column above, we want the cumulative frequency column. So looking at that one, the largest number we've got is 70. So we want to go to 70. And I just want to make this a little straighter. So we want to go all the way to 70. So we just go... Again, we just have to make sure that we cover 70. So I'm just going to go to 80 just to make it easy. So let's say this is 80. Then this is 40, 20, 60, right? We just have to make sure we go to at least 70. So the way this works is we look at our cumulative frequency. I'm going to use a different color here. So I'm going to put this right here, a dot at 44.5. And what that means is that there are zero numbers that are to the left of this, right? There are no data points below or less than 44.5. By the time we get to 55.5, we've got 3. So I'm going to put a dot here at where 3 would be, and a lot of times you'll actually see numbers up here. You don't have to, but you'll see them sometimes. Now by the time we get to 66.5, at that point we've got 10. At 77.5, we've got 32. 88.5, we've got 58. 99.5, we've got 67. Again, we're just getting these from the column under cumulative frequency. By the time we get to 110.5, we've got all of them, all 70 of them. And then when this is done with software, these are going to be connected by straight line segments. Now, since we're doing them by hand, you won't really be able to tell. But it's not like in algebra where you try to fit a line or fit a curve to the points. These are straight line segments. And this is an ogive, and it just shows how the data increases as we go. So we would need a title again. I also need to put cumulative frequency along the horizontal or the vertical axis. Cumulative frequency, need a title. I'm kind of running out of room here, but I'm just going to try to squeeze in ogive for glucose blood levels. And the way you read it, we can actually talk about that in this example right here. Estimate the number of patients with glucose levels less than or equal to 88.5. Well, here's 88.5. Doesn't that mean there's 58 patients with a glucose level less than or equal to this? Really less than, right? Because the data points all are integers. But basically means there's 58 less than this. So over here, 55.5, there's 3 data points less than that. And over here, there's 0 less than that. Over here, 110.5, all 70 of them are less than that. So that's how you read it. But like I said, whenever I've seen these in reality, this is transposed on top of the histogram. They usually show them together. But that is how you make an ogive. So for any of these 3, histogram, relative frequency histogram, ogive, we first put together our frequency table following those steps in the handout. Like I said, it's a little tedious. There's a lot of steps, but we just have to do it in this section. And when you get beyond this class, you'll do all of this stuff with software. Okay, so other than making a histogram, and of course starting with a frequency table, using the frequency table to make a histogram, we're going to look at shapes of histograms. And then we're going to get into more detail with these shapes when we get to section 3.1. But let's just take a look at these shapes, and I'll draw them here. There's better pictures of them on page 49 in the book, but we can do a pretty decent job of them here. So mound-shaped symmetric, this is going to be a pretty important one for us. And it's basically where you make your histogram, and it looks something like this. Mound-shaped symmetric. Doesn't even have to be perfectly symmetric, but it'll be, you know, something along these lines. We're getting into chapter 6, as this will be pretty important for us when we talk about bell-shaped curves. Uniform or rectangular is another one. We won't actually see this one too much. And this is kind of a boring one, but they exist. When we talk about probability distributions, we'll have something like this for if you roll a 6-sided die. What's the probability of getting a 1 or a 2 or a 3, and they're all the same, right? So kind of boring, actually. But this one is called uniform or rectangular. And they just look like this. They're all just look like that. It's not very exciting. Then bimodal is kind of what it sounds like. Bi meaning two, modes. There'll be two modes, so there'll be like a couple of bumps here. This is another one that we won't see too much. The bumps have to be separated by at least one class, so we'll have a couple of bumps. Let's go like this. And, you know, other than that, you can have other things here. But something like this. And this is not a great drawing, but remember that these will be uniformly spaced. So in reality, these bars would be the same thickness. So we got mound-shaped symmetric, uniform or rectangular, bimodal. And skewed left and skewed right, these are ones that we will see quite a bit later on. So skewed left means that you've got this graph and it does something like this. It kind of trails off to the left. So skewed left, it's like it has a tail on the left. Tail on the left. So that is skewed left. And skewed right is exactly what you would think it would be. And they can look different. They don't have to look exactly like what I just drew, but it will be something like this where it looks like it's tailing off to the right. So there's sort of like a tail on the right. And these are just shapes of histograms. And some of them don't fit into any of those shapes. Some of them fit into them perfectly, some kind of. So there's some gray areas, of course. Bimodal, although we don't see it much, it comes up a lot if you combine male and female populations. So if this were a distribution of heights, very often you have two bumps in the data where the mean female height would be and then where the mean male height would be. But these three here are the ones we'll see the most. Mound-shaped symmetric, skewed left, and skewed right. Okay, so those are some shapes. We've also got outliers. And we'll come up with a definition right now. It's not the greatest definition, but we'll come up with a better definition later. So right now for an outlier, I will say these are data values that are very different. They're very different from other measurements in the data set. So that's not a great definition, right? Like, what do you mean by very different? We'll come up with a way to measure it now, but they're just some numbers that seem like maybe they're not right. And they may be or may not be. So the note here is that they may or may not be errors in the data. So let's say you are working in the registrar's office and there's some data coming in with the ages of GRCC students and you're looking through here And in this, you should probably see a couple that maybe could be outliers, like this one looks a little strange, maybe this one. Well, so with an outlier, there's something sometimes you have to look into a little closer, look into this data. Now this one for sure is a mistake, right? 4, I mean, we have some young students, especially in the math department. Sometimes we get some students who just blow through all the high school math all the way through calculus, and they get here. I've had students who are 15 years old in my class. But 4, there's just not going to be a 4-year-old college student. That's probably supposed to be 24 or 40. That one you're going to have to check. Now this one could be a mistake, but we have a math student here who's been taking classes here since the 70s. And some of you, if you've been on campus, may have seen him. He's around in the math department a lot. I don't know how old he is, but he's in the ballpark of this. So outliers are just numbers that, for right now, we'll just say they're very different. We're going to tighten up that definition later. And they may or may not be errors in the data. Okay. Then we've got dot plots. So dot plots are, well, let's take a look. Here's an example of a dot plot. So dot plots, they are good for small data sets, less than about 40, I'll say 40 or so. It's not written in stone, it's just a ballpark. So 40 or so data points. Sometimes they're used in marketing reports. They were real popular in the 80s because you could make them with dot matrix printers. They are still used all the time in medical literature. And they're easy to make. This one right here was made with Minitab. Minitab is a statistical software package that a lot of schools have. It's used sometimes in business, but it's mainly, I would say, in education. Although it's used in research also. It's one that it's out of the main ones. There's like SAS, SPSS. Some of you guys may use these. There's R. Minitab is probably the most user-friendly. And things like SAS, you'll see maybe at a research school. I think even Grand Valley started using this, but SAS, to buy a SAS license is extremely expensive. It's like kind of like buying a small car or a software license. But these are the ones you'll see. You'll see Minitab, you'll see SAS, you'll see SPSS, especially in the social sciences, SPSS and R. This one is Minitab, and this is a dot plot. The nice thing about a dot plot is each one of these dots represents an actual data point. So you can recall the actual data. So it's a dot plot for glucose blood levels, and then of course there's the axis here is labeled glucose. And then these represent the data points. That's 109. There were 2 of them at 45. So the advantage of a dot plot, besides it being really easy to make, even with old computers could do it, like I said, with dot matrix printers. And the other advantage is the raw data actually can be seen on a dot plot. So that's a note here, the raw data. And whenever you hear that phrase raw data, it refers to the actual data. It hasn't been changed. You can just read all the actual data points are right here. So you can see how the data are distributed, right? There's a bunch of the data right around here. There's a few of them out here, one out here. So kind of like with a histogram, you can see how the data are distributed. You can see how the data are distributed here also. And let's see, yeah, Excel does a lot of statistics, but it doesn't support dot plots. It's a little bit strange, but because it does support a lot of other things, but not dot plots. And then one other thing I should probably mention, I had mentioned that this is good for small data sets. So sometimes there'll be maybe there's more data, but you probably have seen this where there'll be a little star that says something like, you see this little symbol and this says this represents 100 people or something like that. So there's kind of some ways you can get around that. So you may have seen things like that. But that is a dot plot, and they are made just by making a number line that covers all the data and putting a dot or some sort of symbol for each individual data point. Okay, that takes care of 2.1. 2.1 is there's a little bit more work in 2.1. So make sure you can make a histogram. You don't necessarily have to make every single histogram to get the process down, but make sure you can make a histogram. Take a look at the homework. Give it an honest try. Like I said, it's a little bit longer, but give it a try. Make sure that it makes sense. And of course, if you're unsure about anything, let me know.